displacement r at the point of interference would be given by r equals y1 plus y2. When both sources have the same amplitude, then y1 and y2 would be equal to y. When y1 is due the crest or trough, and y2 is also due a crest or trough, the resultant would be the maximum. And when y1 is due to a crest and y2 is due to a trough, or vice versa, the displacement would be minimum.
Experiment. We have earlier discussed the phenomenon of interference of waves. Therefore, it is natural to expect that light also exhibits the phenomenon of interference. But interference of light is not so evident as the interference of sound waves. This is due to the very small wavelength of light waves as compared to the wavelength of sound waves. In 1801, Thomas Young demonstrated successfully the interference of light by performing a double-slit experiment. Young allowed sunlight to pass through a hole and then at some distance through two pinholes, S1 and S2. When light was received on a screen, an uneven distribution of light intensity was observed on the screen. A number of alternate dark and bright spots were seen on the screen. The phenomenon of interference can be understood.
The phenomenon of Newton's rings, named after Isaac Newton, is an interference pattern caused by the reflection of light between two surfaces, a spherical surface and an adjacent flat surface. When a parallel beam of monochromatic light is incident normally on a combination of a planar convex lens and a glass plate, a part of each incident ray is reflected from the lower surface of the lens, and a part, after refraction through the air film between the lens and the plate, is reflected back from the plane surface. These two reflected rays are coherent, hence they will interfere and produce a system of alternate dark and
diffraction grating. An arrangement consisting of a large number of equidistant parallel narrow slits of equal width separated by equal opaque portions is known as a diffraction grating. The plane transmission grating is a plain sheet of transparent material on which opaque rulings are made with a fine diamond pointer. The modern commercial form of grating contains about 6,000 lines per centimeter. The rulings act as obstacles having a definite width B, and transparent space between the rulings act as a slit of width A. The combined width of a ruling and a slit is called as grating element.
Okay. Now, I said we were going to use polarized sunglasses. So, first of all, let's find out how they're polarized. We're going to use one of our polarizers that we know which way it's polarized. And put it here in front of the light. That's producing horizontally polarized light. Now we can start with our sunglasses, start rotating them around. So you can see the light makes it through. There it gets pretty dim. Starts getting brighter again. Like that. That's maybe the brightest. And then back around. So it's dimmest right about here. So which way does that mean that the sunglasses are going to have to be polarized? That's right, vertically. So we can go ahead and mark our sunglasses as vertical polarizers here. And now, let's do something interesting. So we have our sunglasses. We have our initial polarizer here. This is horizontally polarized. Sunglasses are vertically polarized, more or less. There we go. I think that's the best I can do. What happens if I use another polarizer, but I stick it in instead of, well, if I stick it in horizontally, it's about the same. If I stick it in vertically, well, it eliminates that light there. What happens if I stick it in an angle? Let's find out. Oh, actually gets bright.